Hello there, we got a pretty quick problem, so let's get to it. The statement reads, the force on a single dipole is P dot del times the electric field E. So the net force on the dielectric object is F equal the integral of the polarization dotted with del times the external field over the volume of the object. Use this to determine the force on a tiny sphere of radius r composed of linear dielectric material of susceptibility chi-e, which is situated a distance s from a fine wire carrying a uniform line charge lambda. Alright, so for our solution, we know that the external field is due to the line charge, which we know from any Gaussian surface or Gauss's law from chapter 2, that's equal to lambda over 2 pi epsilon s, or epsilon naught times s, in the s hat direction. Since the sphere is tiny, this is essentially constant, and hence the polarization is equal to epsilon naught chi-e over 1 plus chi-e divided by 3, which we found earlier in the chapter, times the external field. And then we just have to plug everything into the integral. We know that P is composed of the electric field as well, so that's why we see a duplicate in the parentheses in the second line. Again, since this is done radially, in the cylindrical case, we need ds instead of dr. And then we just carry through. We know that lambda over 2 pi epsilon naught is just a constant, so we're just left with the derivative of 1 over s, which is negative 1 over s squared. Again, all of those are constants, so we push them outside the integral. This integral is of the object itself, which is a sphere. The volume of a sphere is 4/3 pi r cubed. And then we just see a bunch of cancellations, but nothing too terrible. We're left with the force is equal to negative chi-e over 3 chi-e, which again we found earlier in the chapter, times lambda squared r cubed over pi epsilon naught s cubed in the s hat direction. Pretty quick, pretty easy.